is calling you. The universe is calling me. It speaks both day and night. It's full of dark and light.
Hey, hello, and welcome to Sky Tour Radio here on the KGRA Radio Network. You can find us on kgraradio.com if you want to listen along in a browser, or you can download the KGRA Radio app and listen with us. We look forward to hearing from you. This is Mark, and I will be joined shortly, hopefully, by Amanda, who is not here at the moment, and Daryl has the night off, unfortunately, because he is under the weather. Now, here it's clear weather, but we have a full moon, so to me, that's weather. You see, I'm an astronomer. We don't like the full moon. And why is that? Well, the full moon is pretty. The full moon's romantic. The full moon, well, we all howl at the moon. I howl at the full moon, don't you? I guess maybe that's a little too much. I shouldn't have shared that with you. But the full moon is gorgeous at night. But to an astronomer, the full moon represents light, and light is bad for us because we get mad when there's a satellite going through our image. Can you imagine if there's a giant satellite 2,000 miles across that's hanging out in our skies for, half the month? That's what we see with our moon. But you know what? It is something that has made a difference to life on Earth. I won't say that it's responsible for life being able to flourish on Earth, because if the moon was not here, we would still have tides. Yes, we would. We'd still have tides. And for those of you that are thinking, well, how could that be? You're just not thinking quick enough here. The sun is the other source of the tides. In fact, without the moon, all the tides we have on the Earth, all of the tidal motion during our course of our day would be only half as much. Not like a fourth or a fifth or a tenth, but half as much. So you see, the moon does have an influence on us. It does increase the tidal pool size and depth. It increases the way the tides operate. But is it necessarily a good thing to life on Earth? I don't know. I've been arguing against that, actually, because the moon itself has been another gravity well. That is to say, another source of gravity in the local Earth region. And so if you look at the moon, you see how many craters it has on it. Well, yeah, there was a bombardment era. But who's to say that that bombardment wasn't caused by the extra gravity of the moon plus this young Earth? And thus, the bombardment that happened on the moon happened here as well, in part because of the moon. So if we were just an isolated planet circling the sun, maybe we wouldn't have had the same number of extinction events that we had in our past. Maybe we'd have more. But maybe we wouldn't have, maybe we'd have a very different evolutionary track for life on this planet. Isn't that something? It's something I've thought about. I've mused about it in the past. But honestly, I haven't said anything about it because people get disturbed when I tell them that maybe the moon hurt us, not help us, But it's true. I think it's possible, and it has to be something we research. And you can't say it's something that has been, researched to the nth degree. I think there is some research that has been done on whether the moon is necessary for life on Earth. But we only have what we have now. We only have our result to see. So I don't know. Anyway, I want to thank you for joining us here on SkyTour Livestream. That was just a quick full moon type, monologue there for a moment. If you like astronomy, then I would encourage you to subscribe to the companion stream to SkyTour Radio, which is called SkyTour Livestream. It's on YouTube, and we have an East Observatory and soon a West Observatory. I just got back from the West Observatory where we poured the foundation. It looks good. And what is SkyTour Livestream? We call it STLS. Well, it's a clear night journey into the wonders of the deep sky, and it's courtesy of our research-grade telescopes here in Connecticut at the John Zach Memorial Observatory here, and soon in the Western Observatory out in the Sonoran Desert 65 miles west of Phoenix, Arizona. It's a beautiful dark sky, and we can see stellar birthplaces. You can see remnants of dead and dying stars. You can see glittering jewel boxes of stars that are just in rich clusters. And it's also a stream where you, yes, you are in charge if you want to be. I don't have any need to be in the front row. I can let you have the time too if you want to talk about where you want to go, if you'd like to join us online, or if you'd like to come on to our stream and be a participant as with your voice and talk to us. Well, then you can. Many times we have Daryl Mason and Amanda Curran joining us as well, my co-hosts here on SkyTour Radio. So, that said, we have a very active chat group. We can ask questions in there, and if you have an object you'd like to see, your request will not get lost, because our moderators will make sure that I get all of the requests, even if I don't see them, because sometimes I am doing, most times I'm doing 5 things at once. And so in order to get a better feel, they take over sometimes. But SkyTour Radio also has a call-in line. It's sponsored by the Paranormal app, which you can find on Google Play and on iTunes. And the number for that will be given later if we do the call-in line. Right now we're down a person, so I'm not sure that I'm going to do that tonight or not. However, if it is, I will make sure that number somehow gets out into the chat for you. And if you want to talk to us, you can talk to us at skytourradio@kgraradio.com. Whew. All right. Now, you can't count the monologue on the full moon, okay, and whether it hurt us or helped us in our evolution. But that was sort of a long front end to this, wasn't it? Well, talk about long front ends. Here's another one, and this comes from Daryl Mason. See, Daryl is not feeling well tonight, but nevertheless, he was doing some research, and he was talking about a place, and wanted to talk about a place called Abu Huraira. Now, what's Abu Huraira? Well, Abu Huraira is in what is now Syria. It's an ancient site in what is now Syria, but there was a dam that was put up that actually flooded the region. So Abu Huraira is now forever underneath a lake called Lake Assad. Right, in Syria. However, it was a very early human settlement. And the most important thing about this human settlement is that it was a settlement that was transitioning to an agricultural community. Now, amongst archaeologists, that's a hugely important cultural and environmental milestone. And it's really important. And that was what Abu Huraira was doing at the time. I say at the time, that was 12,800 years ago, okay? So that was a long time ago. But that's not what is interesting to astronomers about Abu Huraira. Now you might think, did they erect like Stonehenge things? Did they do things like that? No, not that. It's actually something quite ominous, actually. Now, at Abu Huraira and 30 other locations, not necessarily in the same region, but at different points in the world, including in the Americas. Okay, they found something all at the same layer in the ground, indicating it happened at the same time. And it is what's called melt glass. Melt glass. What's that? Melt glass may also be known as impactite. What's that? It's the instantly metamorphosed rock that turns into a form of glass. Now, we know that when nuclear weapons go off, the desert sands can be fused into glass, basically. Well, this is what we see here at the Abu Huraira site and at 30 other sites around the world. It indicates that there was another impact. And this time, it's an impact that killed humans. Now, we have talked about the impact that killed the dinosaurs. We've never had an impact that killed humans at a scale like this. I mean, there's people that have been hit by meteors and who, maybe they died from their injuries. There was one person I'm remembering in terms of that. But this is a site on the planet, multiple sites on the planet where this impactite and melt glass was found. And just to understand how hot the temperatures were. I can give you numbers like 2,200 degrees Celsius, okay, or, which is like 3,900 or What was it? Oh gosh, it had to be over 4,000 degrees. Basically Fahrenheit or 2,200 Celsius. That's okay. Look at it this way. That is hot enough to melt an entire automobile in 1 minute. There you go. That gives you an idea. Okay. The entire car would be melted in 60 seconds. So this kind of heat was generated at these various regions all around the same time. This seems to come from this impact that occurred, and it's an impact that destroyed humans for the first time. Now, let's talk a little bit more about this melt glass, okay? Now, you remember in your geology classes, go all the way back to high school, and for some of you, all the way back to grammar school where you learn this, and for more of you, the libraries, if you were interested at any one time. We have the three different kinds of rocks. We have sedimentary rocks, like sandstone and clays. Okay, we have igneous rocks, which are spit out by volcanoes, like the lava becomes basalt. And for instance, Devil's Tower in Wyoming used to be underground, and the ground eroded away, leaving the tower because it was a much harder, igneous rock that it was made from, right? And then we have metamorphic rocks. Now these are rocks that are changed due to massive heat and pressure. In fact, metamorphic means change of form, and so this massive heat and pressure would affect the rocks. And for instance, shale over a long period of time can become slate. Limestone can become marble, right? But these metamorphic rocks, again, high pressure and high heat. And at Abu Huraira, the settlement shows a very high heat that happened very quickly. In fact, the building walls and other parts of the settlement literally are sprayed with this molten glass that was formed like this. And this was this is like over 10,000 years ago, right? So we're talking about ample evidence of a cosmic impact that wiped out humans that long ago. And I know you've never heard of this before unless you read some of these journals, or you read the same journals that Daryl Mason was reading. But I thought it was such a fascinating story that I wanted to bring it out. And again, it comes from Daryl. The story comes from Daryl. And so Abu Huraira is a site that I said is in what is now Syria. It's currently under Lake Assad because of a dam they put up. But before this happened, archaeologists were there in record numbers, and they pulled a lot of information and data and samples out of the site. And they found that at this site and these other sites around the world and the region, there's a carbon-rich mat of rock and so forth. And in this carbon-rich mat, there are millions of nanodiamonds. Okay, nanodiamonds, mini, tiny diamonds. And those are also formed from very high pressure and temperature. And there's also, most importantly, spherules, which are little tiny spheres formed at high temperatures, and of course from blast damage. And they're made of platinum and other forms of and other metals. And these little round blobs, because they form at high temperatures, this all led to another hypothesis that's called the Younger-Dryas boundary event, or the Younger-Dryas boundary strewn field is another name for it. So if you look that up, Younger-Dryas, Dryas boundary, and check it out, then you'll see more about it. And the theory was sort of on the fringe, but it's become a little bit more mainstream now, especially since the finding of a very large crater under the Greenland ice sheet. You may recall that find. Okay, up in the northern part of Greenland, underneath the ice sheet, is this deep crater that we don't see because it's under the ice. So keep an eye out for the Younger-Dryas boundary event information. Okay, that's Younger spelled like Younger, and Dryas, Dryas, and then look for that and check it out. Now, going back out into the sky, there's something going on that we've talked about before. We know that Betelgeuse has been dimming. Well, Betelgeuse is now brightening again. So for all the people that thought that Betelgeuse was going to create a supernova eventually, which we know that it should, Okay. Um, we know that Betelgeuse dimming would only be caused by the star getting smaller in diameter. Okay. But the smaller diameter there's a lot going on here. As a star shrinks, it means its temperature is going to increase a little bit. And the brightness of a star depends on the fourth power of temperature. That's a huge factor in determining how bright a star is. But it also depends on the square of the radius. So, a star that's 1/4 of its size that it used to be is 16 times less bright, for instance. So this means something to us. And so when we look at how Betelgeuse is now brightening again, the only thing we can come up with, and a study was done to show this actually, it looks like Betelgeuse as a giant red star, we call them red supergiants, is near the end of its life. And what happens is these get so big, and Betelgeuse is really huge. If you put it where our sun is, it would go all the way out to the orbit of Jupiter almost. So it's not a small star. Those outer layers on the outside of the star just need just a tiny push from radiation inside, radiative energy coming out, to actually make them become free of the star. And then they drift away. And way out there, molecules can form because the temperature is not hot enough to break up the molecules and thus the atoms into, the plasma that we see in our star's surface. And so this stuff drifts away. And perhaps there was this gigantic bubble of stuff that drifted away from Betelgeuse on the outer edge. If we, again, using our solar system as a guide, perhaps it went out as far as, Saturn, or maybe a little, out past Jupiter, in between Jupiter and Saturn. Maybe that's how far out this blob went. And because it was lower temperature, it was also made of dust and so forth that might have formed in the outer atmosphere of the star. And it would have obscured Betelgeuse slightly. And that might be what we were seeing. That might be exactly what we saw. We can't say for sure, but we do know that Betelgeuse is on its way towards supernova. I just want it to happen now. It's a beautiful, clear night now. If Betelgeuse went supernova right now, I'd have to say, folks, I'm sorry, but I'm going to have to go. And and I'd leave Bill, the producer, going, what just happened? What just happened? Where'd he go? Well, where I would have gone was out to the observatory to open it up and train everything on Betelgeuse so we can actually start getting information about Betelgeuse. But you see, I am devoted to you, but I am also willing to, willing to bend the rules a little if there was some kind of major event that was occurring. So anyway, Betelgeuse is finally brightening again. And, Betelgeuse kind of points something out to us, and this takes us to our main topic tonight. We don't have a very good understanding of the universe. There are some things that we know very well. And, science does serve us well, and most of the time, but then there's those cases where it doesn't. And we're going to talk about these shortly, but they're, I call them unexplained phenomena, right? Well, here's some phenomena we do understand. It was just a few years ago when the Chandra X-ray satellite looked at a gigantic, massive, supermassive galaxy in the constellation of Virgo known as Messier 87, the 87th galaxy, to be cataloged by Charles Messier in the 1700s, who was trying to catalog objects to avoid if you're looking for comets. It turned out that the things to avoid are some of the more interesting things in the whole night sky. Well, Messier 87 is 55 million light years away, meaning the light from it we see today left it 55 million years ago. So it may very well look somewhat different today. But in the middle of Messier 87, and perhaps the reason it's so big, is a gigantic black hole that is many times the size of our own solar system. All right. And this black hole is big enough that we could actually try to image it. And we did just that. And some of you out there who know this story are thinking, oh, yeah, I know what that is. That telescope was called the Event Horizon Telescope. Now, what is the Event Horizon Telescope and why was it so important? Well, it's the first time we've ever been able to combine the observations of multiple telescopes around the world into one giant logical collection of observations that approximates a telescope that's the diameter of the Earth in size. Now, how does that work? Well, if you can imagine when the sun rises in California, okay, and again, the Earth is rotating, remember, the way the Earth rotates, the Earth is rotating toward the east, okay? And as the sun rises, you have a telescope that comes alive in California and aims at Messier 87. And it listens to it and watches it all day long, okay, and all night long, because radio telescopes can work day or night. And when it looks at this Messier 87, it captures one swath of data across that part of the United States. So that's one little strip all the way across the United States that it caught. Now, let's suppose we had another telescope about, 500 miles south, and it looked at Messier 87. Now we have another swath all the way across the Earth of observations from all day long. Then you do the same thing all around the world, and it doesn't matter where in the world they are, because the Earth keeps, rotating. So now you build up, let's say 8 to 10 swaths across the face of the Earth. Those observations can rudimentarily be made into a gigantic 8,000 mile diameter telescope. And using that resolution from those observations, we were able to see the black hole, the supermassive black hole that's in the middle of Messier 87, 55 million light years away. Now, this is something that science did well, all right? And we even predicted what the black hole would look like based on relativistic calculations. We expected we'd see a dark hole in the middle, basically, which is the basically a shadow of the black hole, if you will. And then we would have a bright half ring on one side and a somewhat dimmer half ring on the other. That was the prediction. But it turned out that's exactly what we saw. That's exactly what was produced. In fact, it was so close to being what we think it should look like that conspiracy folks were saying, see, that's computer generated. That's not real. It's the same thing that they said that the calculations showed it would be. They literally said that. Well, yeah, 1 and 1 is 2. I can calculate that for you. And then if you can take two objects and put them together and say, hey, that's 2, make that into a conspiracy, he said 1 and 1 is 2. That's why it's just, no. It doesn't make any sense. So this is something that science did well. It was actually able to predict correctly what the black hole would look like based on relativistic effects. Now what happens, though, when science fails? That's something else. See, science doesn't always work for us. Sometimes science works against us, as a matter of fact. And, the universe tosses very perplexing mysteries at us every turn, You may remember a few years ago, the Hubble telescope imaged the pillars of creation. Now, that's another Messier object. That's called the Eagle Nebula. It's Messier 16. All right. And it's in the summertime sky. And we noticed these giant pillars of gas and dust in there. And it was like, wow, what a phenomenal region. And we realized quickly that it's a region where no life could exist as we know it, because the radiation was so intense that the radiation was causing hydrogen atoms to glow very brightly. And if they're glowing very brightly, it actually means that there's a huge problem for organic life like us. So we know that these mysteries are something that the universe tosses at us. We've tried to figure that out with the Eagle Nebula. But, where does science fail? Where doesn't it work? And that's part of what we're doing tonight, is we're going to talk about where science actually fails. And I'm going to draw upon some experiences I've had that I cannot explain. I used to be an arrogant astronomer. I was the AA astronomer, and the A could stand for a lot of things. I basically based everything on science and said if it doesn't show up, in science and it doesn't exist, that was the past. All right. And so my eyes were open to a more open-minded approach, actually quite a long time ago. But I feel that it's something that had to happen, and I'm really glad it did. When we come back on Sky Tour Radio here, we are going to talk about where science fails. We're going to start in with some of the things that we can't explain and some of the things we had to invent in order to make our physics continue to work. And I'll tell it to you in a way that everybody can understand. I mean, that's what I like to do. So, hey, stay tuned. I'll be back. And by then, I am sure Amanda will have joined us, and we'll be able to talk to Amanda as well and see how she's doing. In any case, this is Mark D'Antonio for Sky Tour Radio with Amanda in the ether. And we will be right back after these words.
Why is it we're not very good with our health regimen until it's too late? We don't put oil in the car until the engine blows up. When the body's out of balance, your health is not so good. Give your body some love. Log on to GetTheT.com. That's GetTheT.com. Try our Life Change Tea, which cleanses you from harmful intruders. A clean colon is one of the ways to bring the body in balance. We also carry organic supplements to help you get where you need to go. So do your body a favor. Log on to GetTheT.com. That's GetTheT.com. You can even visit our sales page to save some dough. Does anybody call money dough anymore? Anyway, if you're looking for short, helpful health tips, go to YouTube and punch in Health Matters Now. That's Health Matters Now. So, log on to GetTheT.com, shop, get balanced, then learn some cool tips at Health Matters Now. You'll be glad you did. That's GetTheT.com. Folks, this is very important information. What's to be said about CBD? AncientLifeOil.com. Our CBD is made from hemp and has 0.003 THC, which means this wonderful product won't get you high, no matter what amount you take. What does CBD do for the body? My hands are tied, but you can Google CBD benefits and be astounded. When you're finished reading, you'll want to log on to AncientLifeOil.com. That's AncientLifeOil.com. and purchase. Life is good when you feel good. People are tired of pain. People are asking for non-GMO organic products to help them with you fill in the blank. Legal in 49 states, and again, our CBD is made from hemp. Ancient Life Oil is about helping people one by one by one. If you wonder how good the product is, the CEO takes it every day without miss. AncientLifeOil.com. That's AncientLifeOil.com. Have a great day.
Hey, is that a new music app?
Yeah, check it out. Surfer Music Discovery. It links to thousands of online stations, but the twist is you see the song names and artists that are now playing live.
That's different. No guessing. Looks like a waterfall of music.
So many formats. Rock, oldies, country, R&B, jazz, and a whole lot more.
How's that spelled?
Surfer. S-U-R-F-R.
Is it expensive?
It's free. No need to sign up or sign in.
Get the Surfer Music app free from Google Play or the App Store.
Join me, George Norrie, in Indian Wells, California, May 29th to June 1st for the Contact in the Desert UFO Conference, an epic weekend of exploration into UFOs, ancient civilizations, crop circles, and so much more. Over 150 lectures, panels, workshops, and events with leading experts: Paul Hellyer, Linda Moulton Howe, Nick Pope, Emery Smith, Stephen Greer, Russell Targ, Doc Wallach, Leslie Kane, and more. Get your tickets at contactinthedesert.com. It's time to make contact. Contactinthedesert.com.
More ways for you to make contact. Live Discord chat rooms, live talk radio, live video cast, toll-free HD phones, and coming this year, live streaming TV, giving you more ways to make contact. Your KGRARadio.com.
Hey, welcome back to Sky to Radio. This is Mark D'Antonio, and I'm here to expand your mind. Well, I guess that's a good way to put it, isn't it? So expand your mind as I try to expand my own. And I do have an update. Our wonderful, lovely Amanda will not be joining us tonight. She has also fallen ill under the weather, and it happened very suddenly. So I wore deodorant, so I'm not sure what it is, but I guess that's those are the breaks. So not a big deal. I've done astronomy myself for many years, so I will just go with the flow here, you know. So when I say I was want to expand your minds, basically that's sort of a little lead into the next topic. When we talk about where does science fail us? Well, our science unfortunately fails us when we talk about basically how old the universe is. I mean, a simple question. It's like, well, how old are you? How old am I? You know, we know our ages, but the universe is different. See, the universe was here long before any humans were here, long before any life forms at all existed on the planet. So trying to look back in time is hard. We can't really adequately do that. Excuse me. So the way that we figure out how far back the universe goes in time is by measuring the expansion rate of the universe. Now, why is that important? Because if we can measure it and know how fast the universe is expanding, and we get that rate, we can reverse engineer and go backwards to where it was not expanding. Go back to year one, year zero, time zero. Well, we did that. In 1929, Edwin Hubble was studying distant galaxies and discovered they were running away from us at fairly high speed. The further away they were, the faster they were moving away. And he came up with a constant called the Hubble constant. It was the rate of expansion of the universe. Now, all through getting my astronomy degree, we use the Hubble constant as such, a constant. Well, it turns out that the Hubble constant's not, right? It is not a constant. And it turns out the universe is expanding faster than previously thought. As a matter of fact, it's accelerating outward. Now, that doesn't work for our physics, okay? Because there used to be some trains of thought on what the universe was. Well, if it exploded from the Big Bang, which is still what is believed, then the initial acceleration outward would be slowed as the universe expanded. In fact, the rate of acceleration would slow down. It's accelerating. It's going the wrong way. I mean, exactly the wrong way. So, what does this mean? Well, for one thing, it means that the universe isn't as old as we think it is, because if it's really accelerating, working backwards and figuring out how old the universe was or is, it takes us back to not 13.8 billion years, which is what we were classically told and figured out from the working back and reverse engineering of the Hubble constant. But actually, it's more like 12.6 maybe billion years old. And that means that intelligent life comes about faster in the universe than we thought. And that's a really interesting development. Another interesting development is we found a planet, a singular exoplanet so far, that's over 12 billion years old. Now, if it was 13.2 billion years old, that'd be kind of a problem, especially with our accelerating universe that's speeding outward, and working back, getting an earlier age for the universe would put the universe as being younger than the planet, which can't be. So therefore, we have to be thankful that so far we're not finding any planets older than 12 billion years. But it shows you that planets were forming very early on, and we know from our exoplanet roundup that we'll be back next week, by the way, on these and other KGRA stations. Well, we know that these exoplanets can survive and persist for a very long time, So what do we do with this expansion rate? I mean, that is a problem. Well, we didn't know what caused the universe to expand and accelerate outward like this. And they came up with an explanation saying, well, there's got to be something outside maybe that's causing the universe to like repel away from things, or to I'm not sure what's happening, and then they came up with an idea, and there was probably some guy in the back who said, hey, let's call it dark energy. Frank, what are you talking about? Dark energy. Well, we don't know what it is, right? So it's dark. And that's why they call it dark, because not because it's black, but because It is an unknown. And dark energy is a repulsive force which causes the universe to accelerate outward. It drives space apart from itself ever quicker. Think about that. Driving space itself apart ever quicker. And it sounds like we know what it is, but guess what? We don't know we do not know what it is. All right. So that's part of the problem. It really is just a mathematical construct to explain the observations. But what we do know is that it makes up around 73% of the known universe. Yeah, 73%. Wow. Now, in a way, space itself, we talk about space and we talk about the fabric of space, the space-time continuum. Well, the fabric of space, it acts like other mediums, okay? And let's do a comparison to water. It certainly isn't water. It certainly doesn't act like water, but water can illustrate a principle. If I throw a pebble into water, you know exactly what happens. You get a bloop, and you see rings moving away from the source of the impact of the pebble. Okay? Those are waves. And in space, which is not water, we still see the propagation of waves. And, for instance, we see gravity waves. Yes, sirree, gravity waves. What are those? Well, imagine areas of higher and lower gravity expanding away from the source of a major gravitational event. Things like the collision of two black holes, the collision of two heavy, massive, very massive neutron stars. Okay? When this happens, gravity waves emanate away from that source spot. And gravity waves are something that propagates through a medium. Water's a medium, and the wave, the wave from the rock, the pressure wave of the rock hitting the water emanates away from the source of the impact. And we see it on the water. Well, on space, we quote-unquote see it as well with gravity. So gravity is causing the space-time fabric to warp and distort, which, by the way, as a little aside, is actually very important to another interesting possibility for going faster than light with a spacecraft. That's called superluminal, by the way. Superluminal theories have been around for a long time. And we know Star Trek with Gene Roddenberry, Scotty, I need more power. And, of course, Scotty'd say, I said it. I'll give you all I got. And off they go at several times the speed of light. Well, that was all just, pretend science fiction. Until Miguel Alcubierre came around in 1994, a Mexican astrophysicist, and he decided that he thought there might be a way to violate the speed limit of light speed in the universe if you could use the fact that gravity distorts space. And that's what he did. He figured out a way to fold space. So you take something far away and pull it closer to you by folding the space in between. Okay, just like taking a piece of paper and folding it, corner to corner, and now the two corners are right next to each other. Now, those two corners are never near each other unless the paper is deformed, right, and folded, and that's what you get. So if you then fold those papers together, let the two corners come really close, and then you just jump across or move across at a reasonable speed that the ship can handle, and then unfold space, well, guess what? You're over at that other place now. And you've gone, say, the distance of from here to Alpha Centauri, which is 4.3 light years away. You've gotten there in maybe a week, which is actually plausible within the Alcubierre metric, what we call the Alcubierre. Well, it's a tensor. For those of you in mathematics, you can look that up. And so Alcubierre figured that this was really cool, and of course, it needed such an immense amount of energy to generate the field around the ship that could bend space. But Sonny White at EagleWorks Labs, a NASA-funded lab, is actually funded to explore this because the prospect of moving faster than light has just become more plausible, especially with the detectors that have found these gravity waves emanating from black hole collisions and things. And we'll talk about that again at some point. And that was actually just an aside from the expansion rate of the universe and why it's causing us problems. And how we've had to create dark energy as a stand-in object that we don't even understand yet. It couldn't very well be there, but we we just don't know what it actually is. And that really is kind of unnerving. So that's where science doesn't work for sure. Now, there's other oddities that we can't explain either. And for this, let's take a look now. And this is, again, where science doesn't really seem to work. If we look at the way planets orbit the sun, Mercury is closest to the sun. It takes 88 days to go around the sun, which means it's orbiting at a fairly high rate. Now, Pluto was all the way at the other end of the spectrum, far, far away from the sun. It does not go around the sun in 88 days. It takes hundreds of years to go around the sun because it's so far out. So things nearest the sun orbit faster than things farther away from the sun. It's Newtonian physics, basically. You in orbital mechanics, you understand that things that are orbiting something else can move slower around the object if they're farther away. And that's all good. Well, when we look at the way that stars orbit galaxies, let's start with our sun. We're 2/3 of the way out from the center of our galaxy. Actually, our location in the galaxy has been upgraded to being a little bit closer toward the center. So not 30,000 light years, maybe 20,000, maybe 25. But we're orbiting the galaxy as well. We're going around the center of the galaxy. And so far in the 4.5 billion years we've been around, we've done that just about 20 times, not quite. So our stellar neighborhood around us has changed all throughout time. And that said, as we're orbiting the galaxy core, we've thought that maybe the stars closer to the center of the galaxy would be orbiting faster. And the stars farther away from us from the galactic core would be orbiting slower. You would think. That's just what we thought. Well, it turns out that that's not what's observed. What's observed is that the star velocities do not decrease the further out they go. In fact, they accelerate. They get bigger. Oh, man, this is really messing with our astronomical, understanding. And these are part of the reasons why arrogant astronomers turn docile and blubbering all the time, because the universe can figure out a million ways to not only kill us, but to take our heads and turn them into mush. Okay, the farther out from the center of the galaxy that you get, you would expect, as I said, the velocities of the stars would decrease because they don't need to go as fast to make it around the center. In fact, when you look at it, it's as if the stars are all rotating in the galaxy like a rigid disk, meaning the stars really, really far from the center are moving at monstrous speeds compared to the stars in the center. Now, there is a slight deviation. It's not just a linear line. It's actually, there is a curve that it follows. So, but that said, that's what we see. And you have to wonder, well, if we're seeing that, it means that either our Newtonian physics is broken or there's something here that we don't understand. And so Frank, again, over in the back, said, well, what about, let's call that dark matter. Hey, Frank, you're on to something. First dark energy, now dark matter. Okay. We'll call it dark matter. You said, yeah, dark matter. Okay, dark matter it is. And it became dark matter. I'm being flippant, but that's not exactly, there was a lot of research to get to that point. But if you think about it, when we look at how galaxies rotate and basically how much mass has to be present, it turns out that there's probably, along with the 73% dark energy that makes up the universe, 23% is dark matter. Again, dark energy, dark because we don't understand what it is. Dark matter, dark again because we don't know what it is. And let me tell you, this is not something that I take lightly, but I will say that I think that we are looking at a revolution here in physics. We really are. We only understand 4% of the universe. All right, 73 plus 23, 96%, 4% left over. Right. However, and that 4% is made up of what we call baryonic matter. That's baryonic, baryonic matter. That's protons, electrons, muons, gluons, and so-ons. Okay. And this baryonic matter is something that we understand. Okay, we got to Mars with it. We got to Pluto with it. We invented we checked out Ultima Thule with the New Horizons probe because we understand the baryonic matter and how it works. But there's a problem with that. That's the 4% that we do understand of the universe, and I just thought I'd throw in that of that 4%, 2% is missing. We can't find it. So my question to all the KGRA listeners here tonight is, do you have that 2% of the missing matter? We need it. Thank you. If you just deliver it, deliver it to the office. No one will say a word. Just deliver the missing baryonic matter, the 2% that's missing. Just put it there. Don't have to leave a note. Okay, no questions asked. But we need our baryonic matter back, folks. Okay. Now the problem with that is that from what we understand, all right, this baryonic matter, we only see 2% of the 4%. The universe couldn't have happened because when you add up all the mass, including the dark energy and the dark matter that may or may not, but must be there. You like the way I said that? May or may not, but must be. Okay. Adding that all up, adding all the baryonic matter that we know of, the universe doesn't have enough mass to have actually had a Big Bang. Oh boy. So now what? Well, there's a possibility. The possibility is that maybe, and this is one that I have come to believe, okay, in my little astronomy mind, maybe the Big Bang is just a little squirt off a much bigger bang. Yes, a little squirt off a much bigger bang. And what does that mean? It means that maybe the Big Bang is part of the overall mass load that was available for the Big Bang. And what ended up happening was that it ended up being that the universe basically exploded with another Big Bang, and there were these little side events that might have occurred, including ours. So all that we see, the entire universes that we understand, I say universes because there are quite a lot of papers out in the Astrophysical Journal and other journals, Science, Nature. There's the possibility that multiverse concepts are at play here. And there are some people out there which will say, well, yeah, of course, parallel universes. Well, you say the words flippantly. You say them because you might actually believe them. But the fact is, how do we even know? We really don't. We really don't. Again, we're humans. We have subjective experiences. We look at things and we make deductions based on our brain power, which, with comparison to, say, an advanced alien race, is probably actually substantial, but not evolved. We can make life or death decisions against an alien race and do serious harm to an alien species visiting us. But we don't have the evolutionary background to actually work their existence into our existence. Now, what does that mean? It means that we can't coexist with other species at the moment, other than the indigenous species that are on the planet, animals, insects, etc. Because the alien races may bring other types of biological contaminants unbeknownst to them, or maybe knownst to them. And this could cause us serious problems. But, you've heard the whole notion, shoot first and ask questions later. Boy, that's really helpful. Yeah, it's helpful if you're being attacked from all sides. Yeah, but it's not helpful if an alien race comes down and says, hey, can we be friends? And a bullet whizzes right in and parts his hair in the middle. And it's like, not a good idea, So when we talk about subjective human experience, what are we talking about? And we talked about multiverses and parallel universes. We talked about how our universe might be a little spurred off of a bigger bang, maybe just a little pop. Okay. But, who or what might exist in those other universes? Is there even other universes where life can happen? I don't know. I would like to believe so. Okay. Now I'll give you an example. There's a theory out there that suggests that maybe if we look at some other universes, that maybe in the other universes, maybe atoms can't form the same way they do here. Meaning, for instance, that maybe a carbon atom couldn't exist in another universe because of limitations there that we can't even at this point imagine. So that's why I stutter a little bit trying to talk about it. And so that being the case, if we take a look at, say, a carbon atom, we know the carbon is the granddaddy. I've told you this before, the granddaddy of all elements in the periodic table. We are carbon-based creatures. We are made of carbon atoms. And thus, we're made of carbon, we're made of hydrogen, oxygen, nitrogen, phosphorus, and sulfur, basically. That spells chomps, not chomps. Okay, the M would stand for something like magnesium or molybdenum, but no, it's N for nitrogen, so chomps. And so that's the basis of DNA. That's the basis of human life. And what's interesting is the carbon-based life forms on this planet require oxygen to make energy. That's crucial. That is hugely crucial. And in our discussion here, when we're talking about the subjective human experience and how we look for life elsewhere, and if we're just a little pop off a bigger bang, what about life elsewhere? Well, certainly there's life elsewhere within our little pop, our little mini universe, so to speak. And that's kind of what we're focusing on. We can't see into multiverses yet. I say yet because I think that'll be possible at some point. But what are we doing? We're looking for other planets, other exoplanets around other stars that actually have an atmosphere in which there is that amazingly intricate element that carbon uses to make energy, and that's oxygen. And the oxygen atom is ubiquitous in the universe. It's everywhere we look. There's a lot of places where it exists. It's in the atmospheres of some of these exoplanets, as we've already discovered. But some of them, most of those planets are not habitable, yet still there's oxygen there. So clearly oxygen's being made in stars. We know this. We've known this for a long time. In fact, one of the fusion, there's only two ways that stars can make energy, and that's using what's called the proton-proton approach, which uses hydrogen atoms to make helium, or using carbon, nitrogen, and oxygen atoms called the CNO cycle. And that eventually makes helium as well. So there's one of two. So clearly carbon, nitrogen, and oxygen are all made in stars as well. And that being the case, this is something that is really, I guess, if you say, since the carbon atom is so plentiful, we know that it wouldn't be wrong for us to look for life like us. Oh, yes, I'm a carbon bigot. You can go right ahead and say it. You're a carbon bigot. Yep. Okay, so I am. Yeah. Why? Because we know what carbon-based life looks like. We know what to expect. We also know that the carbon atom bonds with more things than any other atom in the periodic table. Yes, you can make more compounds with carbon than any other element. More. Vastly more. So the flexibility of carbon is part of the reason why the universe has a carbon-based life. The universe is just reacting to the availability and capability and characteristics of this carbon atom. And so here we are. Now we're carbon-based life. We also have, as I've talked about before with you, we have this bilateral symmetry, don't we? Across our middle, we're symmetric on both sides with the way we interact with our environment. That's important too, because every life form on this planet has that. Every multicellular life form has symmetry. In fact, the way cells divide is symmetric. And it's all based on DNA. It's all based on the fact that when DNA is replicated within our cells, the DNA helix unzips, and now you have one half. Notice I said half. That goes to another location in the cell, a special location where that's called RNA at that point. And that RNA, ribonucleic acid, is zipped up again with another matching copy of a complementary copy to make another strand of DNA. And that's how DNA is replicated in our cells. And that is something that may be the reason why we are symmetric beings, why we're bilaterally symmetric. We're not exactly the same on both sides outwardly, but that's due to some of the potentially the genetic variations that occur from time to time in human beings, even at on a per being level, per animal level. So that whole process means that there's other life out there in the universe. We did not create this DNA. It happened naturally here. We didn't create carbon-based life. It happened naturally here. So what is that? It's a template, folks. It's a template for life in the universe. It's a natural template. This isn't any kind of religion. This is science. This is science. We have existence because of a template provided by the universe, either advertently or inadvertently. So I think that's kind of cool. So now, when we talk about parallel universes and is there life in another universe, I might have told you that it's fanciful to think about it, but I don't know if that's true until I had an experience that I cannot explain. And that experience has to do with something that occurred when I was working on a movie here. It was a movie with Douglas Trumbull, who's famous guy. Everybody knows Doug Trumbull. He's a special effects magnate, a good friend. And we're going to talk about this when I get back, because I think you're going to like where this is going. In any case, this is Mark D'Antonio with SkyTour Radio. I'll talk to you in just a moment.
Join me, George Norrie, in Indian Wells, California, for the 8th Annual Contact in the Desert UFO Conference, May 29th to June 1st. Contact in the Desert is an epic weekend of adventure filled with exciting explorations into UFOs, ancient alien civilizations, crop circles, forbidden archaeology, disclosure, leading-edge science, and the newest evidence of ongoing contact, sightings, and leading-edge science. This amazing weekend offers lectures and workshops, exciting panels, and a luncheon that I'm hosting. Contact in the Desert also features leading experts including Linda Moulton Howe, Paul Hellyer, Stephen Greer, Emery Smith, Russell Targ, Doc Wallach, Leslie Kane, and many important researchers and scientists from all over the world. With the breaking articles in the New York Times and acknowledged naval sightings, Contact in the Desert is your place for inside information. Join us at contactinthedesert.com to get your tickets today. It's time to make contact. That's contactinthedesert.com. Contactinthedesert.com.
Hey, this check is wrong. I worked a holiday and 7 hours of overtime. Not getting paid correctly is a real pain. It could also hurt our boss if our company provides out-of-compliance checks. That's right, construction companies doing business with the government can get fined, or officials of the companies can go to jail if the checks aren't right. It's a law. The Davis-Bacon Act has 30 compliance issues for every check, but there is an easy way for construction companies to be in compliance. EMARS offers Compliant Client, a web-based system that finds and corrects all 30 of the possible out-of-compliance check issues. Users of Compliant Client report an 80% savings in time and money. Running a weekly payroll usually takes about 5 minutes. All 15,000 plus clients of EMARS have never had a legal compliance issue. Plus, they sleep better on check day. Contact EMARS at emarsinc.com or call 480-595-0466.
Folks, this is very important information. What's to be said about CBD? AncientLifeOil.com. Our CBD is made from hemp and has 0.003 THC, which means this wonderful product won't get you high, no matter what amount you take. What does CBD do for the body? My hands are tied, but you can Google CBD benefits and be astounded. When you're finished reading, you'll want to log on to AncientLifeOil.com. That's AncientLifeOil.com. and purchase. Life is good when you feel good. People are tired of pain. People are asking for non-GMO organic products to help them with you fill in the blank. Legal in 49 states, and again, our CBD is made from hemp. Ancient Life Oil is about helping people one by one by one. If you wonder how good the product is, the CEO takes it every day, without miss. AncientLifeOil.com. That's AncientLifeOil.com. Have a great day.
Mainstream media's most wanted. KGRARadio.com.
Hey, 321 go. This is Mark D'Antonio with SkyTour Radio back again for yet more. It's very liberating, for some reason. I don't have any questions to answer, although I see there are some questions actually that came up in the chat. And it's just nice, and it's just nice to be able to go on here. I mean, I miss Amanda dearly. I miss Daryl. I want them to get better so they can come back and join me. But boy, oh boy, I'm having a really good time tonight talking to you. I feel like I'm sitting with you at the kitchen table just discussing things. So I really enjoy this. And so, and the other thing is, I mentioned before the Alcubierre Drive, and I kind of glossed over it a little bit. But in the break, I was reminded by Bill, my producer, that there was an amazing article about the Alcubierre Drive. And I had looked at this article in the past, and I've seen it. And I'd like to ask him to join us. And I know this is kind of not normal to ask your producer to come on, but I'm going to do it. So, Bill, get your button here, please.
I am here.
All right. This is Bill. This is Bill Skywatcher. He's our esteemed producer at KGRA Radio. I hope out of all this you get a raise, because you actually have some good questions. You do a lot of hard work for us, and now that you're on the air, I'm going to embarrass you and say that I think you're the best darn producer in the history of producing.
I am humbled by that. But yes, I found your first hour, as always, fascinating when you were mentioning the Alcubierre Drive, because that article was fascinating. There was this presentation, and it was conducted by Joseph Agnew, and he was an undergraduate engineering research assistant from the University of Alabama in Huntsville, Propulsion Research Center. And he did a presentation, and part of it was the future of nuclear and breakthrough propulsion. And a lot of it stemmed from Mexican physicist Miguel Alcubierre. Mm-hmm. And this occurred, I think, a few months ago. It was at a conference. There was some type of a conference that occurred. And he did this presentation. Now, before we get into the details of some of his quotes, because I want to hear your reaction on some of the things that he said, that he mentioned. But before we get into that, they mention, and you mentioned this earlier, and I'm going to read directly from the article.
Okay.
While the field is still in its infancy, there have been a number of recent developments that have helped. For example, the discovery of naturally occurring gravitational waves by LIGO scientists. Now, and this was in 2016, which both confirmed a prediction made by Einstein a century ago and proves that the basis for the warp drive exists in nature. Now, before I mention the quotes that were said by this individual, Joseph Agnew, can you explain what LIGO does and what it means, what they discovered in 2016?
Yeah, I mean, LIGO, L-I-G-O, stands for Laser Interferometric Gravitational Wave Observatory. Now, you got that? Because there will be a quiz. And so you're going to have to remember that. So basically, LIGO detectors, there's several of them in the country. There's one in Washington State, there's one in Louisiana, and there's actually another one called Virgo over in Italy. And they all operate the same way. These detectors can detect the gravitational waves when they're being emitted. And based on the timing of when they reach the different detectors around the world, we can kind of pinpoint where they came from. And that really is very helpful to know where they're coming from in the sky, because otherwise they're just big, broad detectors that are detecting a signal from somewhere, but you don't know where. But having three of them means you can triangulate where they came from. And for instance, when we detected gravity waves, we could trace them back to an area where there were two colliding black holes. And I mentioned how gravity waves propagate through space as a medium, and one of the questions tonight in the chat is, for instance, how does an Alcubierre drive manage to bend space? Mm-hmm. Okay, that is by the usage of something called a warp bubble. Now, the concept of a warp, I said warp bubble, like it was a Star Trek, Captain, I am not a warp bubble. But the warp bubble is actually an area around the ship that would actually do the bending, all right? And it uses huge amounts of energy, and we cannot currently harness the amounts of energy that are required to create such a warp bubble. But it does bend the space-time continuum in the same way that a black hole does. Now, we know that light has no mass. The photons of light are massless. They're mass-free, okay? But yet still, black holes can bend their light. I'm sorry, black holes bend photons, apparently. So how do you correlate that? The way it really works is black holes don't bend light. Light is not subject to gravity. However, light follows space. It follows the space fabric in the same way that a car has to go up and down a hill on a road that's going up and down hills. Okay? The hills are the fabric. The car is the photon. It follows space. It follows the curve of the road. Well, space can be warped by gravity. And so when a black hole warps space, light is following space. And so if it goes into a very steep curve from which it can never return, then it goes into a very steep curve. And that's why they say things like, and light can't even escape a black hole at a certain point, And so the Alcubierre drive will create a similar warp to space. But what it does is it compresses the distance from your destination and your origin, meaning if you're going to Alpha Centauri, it makes the distance from Alpha Centauri to you smaller by some degree at the same time that it's expanding the distance between you and the Earth behind you. Okay? That's when the gravity generator, so to speak, is turned on. That is when the warp bubble's active. Now, the Alcubierre ship is still moving through space. But if you think about it, when you turn the gravity generator off, now you're that much farther toward Alpha Centauri. You might have to jump that several times. A way to see how it works better is you can't run at 20 miles an hour, okay? Or if you can, not for long. But let's suppose that you're on one of those flat people mover escalators at the airport. You walk on, now all of a sudden you're walking down this walkway. And to the people walking alongside, you're going by them at several miles an hour faster than they are. But to you on the walkway, you're only walking as fast as you can walk. Yet the airport is speeding by you at a much faster rate than you're going until you come off that flat escalator. So that's the principle behind how you would travel with an Alcubierre drive. You are actually, the universe is rushing past you at a higher rate of speed because of the fact that you have this warp bubble that is the flat escalator, okay, running around you at all times. You step off of it, you shut off the generator, and now it's back to normal. And you're at the other end of the escalator. You've made 20 steps to get to where you are, and everybody else took 45 or 55 steps to get to where you are. So it conserves energy. It actually allows you to get much further, faster, and you can go much more vast distances. See? So that's kind of how it all works. You see what I'm getting at there, Bill?
Yes. It's interesting that you say that, because in his quote, he mentions something similar to what you just described, and I'm going to read his quote right now. In essence, what is needed for a warp drive is a way to expand and contract space-time at will, and in a local manner, such as around a small object or ship. We know for certain that very high energy densities in the form of EM fields or mass, for example, can cause curvature in space-time. It takes enormous amounts to do so, however, with our current analysis of the problem. On the flip side, the technical areas should try to refine the equipment and process as much as possible, making these high energy densities more plausible. I believe there is a chance that once the effect can be duplicated on a lab scale, it would lead to a much deeper understanding how gravity works and may open the door to some yet undiscovered theories or loopholes. And to wrap this up, he says, I suppose to summarize, the biggest hurdle is the energy.
Yeah, that's right. The energy is huge.
And with that comes technological hurdles needing bigger EM fields, more sensitive equipment, etc. So what would it take, Mark, to comprise something on a scale in a ship to provide the energy necessary to do what is needed to create this warp bubble?
Well, we don't have an energy source that can do it. Fusion is woefully inadequate. We would literally need to be able to harness the power of a black hole itself. Now, you might, people out there in the audience are thinking, oh, well, that's the end of that. Yeah, that's not going to happen. Yeah, well, they also said we'll never break the sound barrier either. Okay. They also said that we would never be able to dive to the bottom of the ocean. They also said we'd never be able to get to the moon. Okay. And for those of you conspiracies folks out there, we did get to the moon. Okay. And we landed several times. So like it or not, that's my answer, and I'm sticking to it. And there's proof. So that all said, I think that there will be a time where the acquisition of black hole level technologies won't be that far away. We have to go through the fusion era. We have to get to another era where we're using antimatter, probably, which will be the next level. And then beyond that, we're probably going to end up creating micro black holes in the lab first, and then using those to leverage the creation of larger black holes and possibly, black hole energy objects that will be used to generate some of the energy required here. But, we're talking about what's called exotic matter, regardless. So that's still a ways off. And it's exotic because we can't really put a finger on how do we even achieve it,
Is there any way that we can harness the energy in space? Like we hear like type 1, type 2 civilizations where they can harness the energy of the sun. Is there any way that we can do it in a way or means that way where it can be powered?
Not using the sun, okay. But the sun uses fusion. And actually, in a sense, in maybe 150, 200 years, we'll consider the sun's energy old school. Nowhere near efficient enough to do what we need to do. But the time will come, I think, when we're going to be on that precipice. And, we have to be careful here because and it's sort of a myth in a way that if you create a black hole, you could accidentally eat up the whole Earth. Okay, black holes, when they acquire mass, they will grow in size. So we have to be careful. But black holes also evaporate. Very small black holes will evaporate very quickly. Larger black holes will not. They'll grow to monsters. So we have to be careful. It's the difference between a dust devil and an F5 tornado. Okay, we're talking about a massive difference, and multiply that on either end by approximately 1 million. So clearly, we have to be careful with this technology, and we also have to get past the warrior status of the human race. We got to get past all that anyway. And this is sort of the altruistic side. But if we don't do that, then there's no sense in trying to develop a drive like the Alcubierre drive, because at any point along the way, the drive could be used as a weapon.
True. Mark, it's fascinating because I was thinking, would it be more practical? Because I'm thinking about the conditions on the ship and the possibility of some type of an error, especially if there are humans on board. Would it be more practical to maybe do it with some type of a drone, maybe to go probe exoplanets? Because that's really, you know what I mean?
I do, actually. That was my first thought. I talked to you remember the movie Interstellar?
Yes.
Kip Thorne was a astrophysicist who was a consultant on that movie. And I sat with Kip Thorne for several hours, and he was talking about black holes and how to do time travel with black holes and so forth. And he and Stephen Hawking had an argument going back and forth about whether you could use black holes to actually do time travel, for instance. And this does kind of relate to what you're asking me, which I'm going to remind you to ask me again afterwards. But they actually ended up swapping positions and showing that even the greatest minds on Earth can't figure out the proper results yet when it comes to things like black holes. So in other words, the technology doesn't exist now, and when it does, it's going to take a long time to really get a good handle on it because it's also very dangerous technology. And so we do it on a small scale first. So, yeah, I think we're going to have Coke bottle-sized probes that are going to be sent off to various star systems. We could get to Alpha Centauri in 5 days with an Alcubierre drive that's properly engineered. And we would know in 5 days whether there was life around Proxima Centauri's 2 planets. That's right, 2 planets, not just one. And so we'll have probes that are going to go to these planets, and they will be Alcubierre based. But guess what? Alcubierre technology can get us to go to 4.3 light years in just 5 days. Sounds fantastic. It is fantastic. The energy requirements are stupendous. However, there's another problem, and that is the galaxy's 100,000 light years across, man. So how long would it take you to go 400 light years? Well, if it takes, let's say we're going 430 light years, right? It's going to take you 10 times as long. So it's going to be 50 days instead of 5 days to go 430 light years with an Alcubierre drive, and it's going to have more complications. And now you're talking about extended stays for the crews. So that's just 400 light years. What about 10,000 light years? Now you're back up to astronomical amounts of time that humans have to endure space. So it's not fast enough.
But
if you
now,
want to travel the universe,
you know me with you. I have a bad habit of interrupting you, but I just want to throw this in there, though.
Always do, and it's always good because you're
but
in dealing with you is like dealing with a small Siberian Husky Pomeranian type mix. Okay?
It sounds familiar to me.
They always want something, It's like, wait. What about this? What about this? What about this?
But if you're theoretically traveling faster than the speed of light,
yes.
How does that affect time here back on Earth and the time you're traveling? But that's just one part of it. But let's say if you try to use it in a practical use within our own solar system.
Yes, exactly.
How do you hit the brakes?
Well, that's the thing, okay? You're never going – your ship is never moving very fast. Your ship never moves faster than light. And, again, it goes back to that escalator analogy, okay?
Right.
If you have an escalator, the flat escalator where you're walking on at the airport, and you start jogging on that escalator, okay, now you're moving as fast as you can move reasonably on that escalator. Now the airport's rushing past you in the opposite direction quite a lot faster, right? But let's say that escalator was kicked up a notch to be, say, 10 times as fast. And let's say it accelerated to that speed after you got on, and then you started walking. You could conceivably be walking, for all intents and purposes, at, say, 35, 45 miles an hour, walking. Now, watching you from the outside, if that thing stops suddenly, you would go flying forward, wah,
Yep.
However, from your point of view, you're just walking normally, or you're just jogging, right? The escalator is moving very fast, and of course, it would decelerate and come to a slower stop when you got off. Yet you're all the way across the airport in record time. So the point here is that it depends how fast the escalator goes. And basically, that's how much you can bend space with the Alcubierre drive. And if you have the warp bubble strong enough to actually power it in one jump, let's say you could, and you go 4.3 light years, okay, you fold up the corners of the paper, corner to corner. At one corner, you have Earth. At the other corner, you have Alpha Centauri. If you went straight across the paper from corner to corner, the fastest you could get there is in 12,000 years with our current technology, okay? But with an Alcubierre drive and you fold up space, and realistically, you probably have to do it in multiple jumps, not just one, but let's say one. You fold up the corners and you step across, basically, your ship is moving at a rate of speed that is not at all damaging to the ship. Then when you unfold space and shut off your warp bubble generator, you're at Alpha Centauri.
Wow.
Yeah, and you are there 5 days later than when you left the Earth. So it doesn't do any time dilation problem. It doesn't do that at all because you're never traveling near the speed of light at all.
But
you're completely circumventing it.
But is there a possibility if something goes wrong, you could actually destroy anything in the near vicinity that you eventually end up at?
Well, you were hearing me talk about this in the past because you know that's true. There's several variations of the Alcubierre drive that Bill is alluding to, guys. And I can tell you right now, the standard Alcubierre drive, basically, as you're traveling across the two corner to corners, there's a lot of energy there. And when you do that, the front of the warp bubble is going to gain debris on it, like bugs on a windshield. Okay. And when you turn the warp bubble off, that stuff is going to just blow out at high rates of speed. And if it does, you might be on your ship with your crew saying, "Hey, crew, look at it's Proxima Centauri. There's a whole advanced race here. Look at those satellites. Look at those space stations. My gosh, they're so much more advanced than the Earth." And then you shut off the warp bubble, and the entire system, including Proxima Centauri, gets obliterated like a nova.
Wow.
And then you look at your friend and you twitch a little and you say, let's just say there was nothing here. Yeah. Nothing. Yeah, nothing to see here. We're going home. Yeah, okay. Hey, spin it around. We're going home. Yeah. No, false alarm, guys. Yeah. So that's one variation. That's the original Alcubierre drive. But there's another one that I think it was a mathematician named Froning, Froning. He came up with a way to actually add, are you ready for this? Shields, like in Star Trek, to the Alcubierre warp bubble. And what would that do? The shield basically would allow materials that would build up otherwise on this warp bubble front and be very damaging when you slow down and stop to just ablate off and just sort of like pass around the warp bubble. It's a true shield.
Wow.
And this would protect not only the occupants, but it would also protect the destination system if there was ever any problems. However, if you were an unscrupulous race of Borg that are trying to take over the universe, well, you might just decide that you're going to send one of these suckers to a solar system and at high speed and then stop dead right in front of the planet. Its warp bubble would shed all the energy and boom, you'd obliterate the planet. It's sort of like the Death Star, but multiplied, by 1,000.
But like you said, Mark, it can be on the flip side. It can be used for nefarious purposes as a weapon.
That's what I just said. You're right. And we got to not do that. So we have to be past all of that.
Yes.
Now, I don't think any of this is going to happen before we have solid, full-blown colonies on Mars and the Moon and maybe Titan, okay? Because we are looking forward to that. That's something that we want to do. There's economic reasons for it. There's technology reasons we want to do this. And I think that we're going to eventually be on the Moon with a permanent presence and on Mars with a permanent presence.
Agreed. Now, we got about 3 minutes before we go to break, but before we do, Charles has a question for you in the chat room, and he wants to know, what would an Alcubierre drive ship look like as it passed by?
That, that's a good question, because we're in regular 3D space, okay? You would not see the Alcubierre drive ship at all. In fact, when it was warping space, it would just appear to blink out in orbit. You would see the light. You see the light of the ship up in orbit. Hey, there's the Alcubierre drive. Bye, guys. Hey, it's gone. It just winked out. What happened? Did it blow up? What did it happen? Did it go away? Well, when it activates the warp bubble, it's suddenly going to be much further away, moving at a very, very high rate of speed relative to you. But to them, they're just moving at their normal speed because you're walking on that flat elevator escalator at whatever speed it's moving. Mm-hmm. But the people watching, you could be moving at 50 miles an hour, man, or 100,000 miles an hour, and you wouldn't know it because you're just walking normally, do-de-do-de-do. Okay? But see, that's the relative. That's actually kind of a good way to look at the what we call reference frames, and that's kind of what you'd see now with a Alcubierre drive like that, a Froning version where you actually have the particles being shunted aside that aren't going to build up and cause, get bugs in your teeth on your windshield and then boom, blow up planets. With that kind of thing, you would actually have a good chance of being able to quietly enter a system and see people or beings or creatures going about their business should there be an advanced race. Now, there's a lot of exoplanets out there that we found that are potentially habitable. And when the James Webb Telescope goes up, it's going to be able to analyze the atmospheres of many of these planets.
Finally.
When it finally goes, I know, come on, man.
You know I had to say that because it's been delayed.
I agree.
Now, before we go to the commercial break, folks, I just want to remind everyone that Mark D'Antonio will be taking phone calls for the last segment of his show. You can reach out to us. I will be at manning the phones because, sadly, Mark, I'm going to have to leave you so we can take the calls. But right. And thank you for giving me the opportunity to come on with you for a few moments.
Appreciate it, Bill. Thanks.
So you can reach us at 855-472-5483 or simply 85KGRA Live, and it's brought to you by the Paranormal Radio app. So, Mark...
I said it myself.
Yes. So make sure to give Mark a call. We're going to open the lines after the break. So, Mark, take us away.
All right. Hey, guys. Thank you so much. Bill, thank you for coming on with me. Those are great questions about the Alcubierre drive. It sparked a lot of interest in the chat. So we'll be back right after these words, and we are going to continue with a discussion of my experience with the phenomenon that made me realize that the multiverse is probably a reality. We'll be right back after this.
Why is it we're not very good with our health regimen until it's too late? We don't put oil in the car until the engine blows up. When the body's out of balance, your health is not so good. Give your body some love. Log on to GetTheT.com. That's GetTheT.com. Try our Life Change Tea, which cleanses you from harmful intruders. A clean colon is one of the ways to bring the body in balance. We also carry organic supplements to help you get where you need to go. So do your body a favor. Log on to GetTheT.com. That's GetTheT.com. You can even visit our sales page to save some dough. Does anybody call money dough anymore? Anyway, if you're looking for short, helpful health tips, go to YouTube and punch in Health Matters Now. That's Health Matters Now. So, log on to GetTheT.com, shop, get balanced, then learn some cool tips at Health Matters Now. You'll be glad you did. That's GetTheT.com.
Hey, this check is wrong. I worked a holiday and 7 hours of overtime. Not getting paid correctly is a real pain. It could also hurt our boss if our company provides out-of-compliance checks. That's right, construction companies doing business with the government can get fined, or officials of the companies can go to jail if the checks aren't right. It's a law. The Davis-Bacon Act has 30 compliance issues for every check, but there is an easy way for construction companies to be in compliance. EMARS offers Compliant Client, a web-based system that finds and corrects all 30 of the possible out-of-compliance check issues. Users of Compliant Client report an 80% savings in time and money. Running a weekly payroll usually takes about 5 minutes. All 15,000 plus clients of EMARS have never had a legal compliance issue. Plus, they sleep better on check day. Contact EMARS at emarsinc.com or call 480-595-0466.
Join me, George Norrie, in Indian Wells, California for the 8th Annual Contact in the Desert UFO Conference, May 29th to June 1st. Contact in the Desert is an epic weekend of adventure filled with exciting explorations into UFOs, ancient alien civilizations, crop circles, forbidden archaeology, disclosure, leading-edge science, and the newest evidence of ongoing contact, sightings, and leading-edge science. This amazing weekend offers lectures and workshops, exciting panels, and a luncheon that I'm hosting. Contact in the Desert also features leading experts including Linda Moulton Howe, Paul Hellyer, Stephen Greer, Emery Smith, Russell Targ, Doc Wallach, Leslie Kane, and many important researchers and scientists from all over the world. With the breaking articles in the New York Times and acknowledged naval sightings, Contact in the Desert is your place for inside information. Join us at contactinthedesert.com to get your tickets today. It's time to make contact. That's contactinthedesert.com. Contactinthedesert.com.
Now you have the inside contact for Alternative Talk Radio. The Planet. KGRARadio.com.
And we're back in KGRARadio.com. This is Mark D'Antonio with SkyTour Radio. Welcome, folks. I'm glad you could join us tonight. And I got to just say, it looks like we're probably going to be seeing a manned mission to the moon probably maybe by, say, 2024. And let's suppose we do, and we start putting, bases on the moon and so forth of our own. Do you realize that in 50 years, there's going to be people that say we never did that either? And it was all a hoax, and there's no proof. There's no way that we ever landed on the moon. Blah 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 blah. So you see, the conspiracies will never go away. Just so you know. Now, before the break, we were talking with Bill Skywatcher, our esteemed producer, who was talking about the Alcubierre drive, and we'll just let that sink in. Let you live with that for a little while. And I'm going to just move on now to the other parts. We talked about subjective human experience earlier, and it ended when we talked about dark energy at 73%, dark matter 23%, and the baryonic matter's at 4%, 2% of which we don't even know where it is. So that led to the thought that maybe we have parallel universes out there, because we didn't have enough mass to create a big bang. But maybe we could do like a small pop off of a bigger bang. Maybe we're like a little side road. Hard to imagine that at the scale of the universe, but that's actually very possible. Our universe is about 93 billion light years across overall. That's the diameter we figured out based on all the newest data and so forth. And maybe that's huge for a universe. Maybe it's not. I don't know. But the question is, if there are parallel universes, what may exist in these other universes? And I had an experience that I'm going to relate to you, and it happened here in my special effects shop. I was working on a prop for a movie I was working on with Doug Trumbull, and of course, Academy Award-winning visual effects maven and very good friend. And I was all excited with this prop, and I noticed as I was sitting there, I could still hear the sounds of people talking that weren't in the room. This had been going on for about 2 years. And I thought, oh, great, I'm hearing voices in my head. Ha, I'm one of those. Well, it turns out that I wasn't one of those because it was like I was in a crowded room all the time. And I had brain surgery 27 years ago to save my life. I had something in dead center in my head that was going to kill me. And I had just a few weeks to live. In fact, doctors didn't know why I was still alive when I got into the operating room. They thought I should have been dead by then. Well, as they removed this thing, apparently there was scar tissue. And so I figured that the voices I was hearing was my brain replaying conversations I heard in the past. That's literally what I thought was going on. And so I didn't really think too much of it. I just lived with it, saying, all right, well, like people live with tinnitus, ringing in the ears. I have to live with hearing people talking, conversations I had in the past that just keep getting replayed. Then I started seeing people walking around in my house. And everywhere I went, there were people walking around. They weren't interacting with me. They weren't saying, kill your dogs, kill your dogs. They weren't having me do anything. They were just saying things to themselves and each other. So not only did I hear voices like I was in a crowded room, I saw people talking and walking by like I was in the middle of crowds when I never, ever had that happening. I was in my house all alone many times, and I saw this happening. So I even started taking medication so I could help focus and get away from the noise because I wasn't being very efficient in my shop. I didn't want to cut off my thumb because some lady's yelling at me from the right side who wasn't really there, so to speak. Well, this is the precursor of what happened. So now when I was looking at this prop I was building, I was really excited about it. It was 3:30 in the afternoon. I was going to pick it up and drive it up to the studio, show it to Doug. Doug would eventually love it, which is great, Well, anyway, as I'm doing that, I see this little dog, semi-transparent, because all these people and everything were semi-transparent. They were kind of like half there, half not. Semi-transparent people show up, and then this dog shows up. The dog comes into my shop, and it turns around and lays down and starts doing something. Maybe it was licking itself. I don't know. I didn't want to know. And I'm staring at it, thinking I got something in my eye. Is this one of those things, or is this my eye? So I'm blinking at it. It's still there. I stand up. It's still there. I walk over to it. It's still there down below me. So I did something that I thought was crazy even to me at the time. I stepped where it was. I stepped in its space. And it felt that, apparently, because it got up and started running out of the room, out of my shop. Like I kicked it or something. I immediately felt bad, but I didn't have long to feel bad because as it ran away, it took my leg with it. And my foot swung out from under me like it was on a freaking elastic. And first thing I saw was my left foot. I saw my left foot in the air. I saw the lights, and I thought, it goes in slow motion. It's like, oh, my left foot's in the air. Why is it up there? And I felt like my knee had been broken, like hyperextended, snapped out. It really hurt. And then I saw my right leg coming up, and then I hit my right shoulder on a workbench, and I landed kind of on my left side on the ground on concrete, and I whacked the back of my head. And I got up, and I was absolutely elated. I was stunned, hurting, and I was like, wow, what was that? Ow, ow, what was that? Oh, ow, my head. I thought it was amazing. So, two things here. What could it have been? Could it have been a figment of my imagination? Well, I wanted to find out. I went to the doctor. I told him what I saw. And after they stopped looking at me funny, they put all kinds of sensors on my head, and I ended up doing many of these EEGs, electroencephalograms, where they even took home these overnight ones. I was wearing a headband, actually a total skull head cap, basically, of gauze with sensors installed on my head. And every time I saw one of these things, I would push a button saying, okay, saw one, click, saw one. And that was to do the diligence. That was my urging to do this. I wanted to make sure that I didn't have a medical issue. They thought, well, maybe these could be micro epilepsy seizures. So let's rule that out. And it was ruled out immediately. There was no seizure events, nothing like that whatsoever. They had nothing on the brainwave test that showed any objects at all. Yet there they were. I was looking at them. So anyway, what could it have been? Well, I don't know what it could have been, but I thought about it later, and I thought, maybe people would call this a ghost. Maybe this was like a paranormal type event, a ghost. And I thought, well, let's take this a step further. Okay, what would a ghost be once we understand it scientifically? Maybe we're looking at, and this is a term I coined that a number of people have actually run with, bleed through from a parallel universe. And I called it a parallel universe intersection, a PUI. And it was just because I got tired of saying bleed through from a parallel universe. It was a parallel universe intersect. And that was my thought. And I thought, what if that's what ghosts are? People that see things, maybe they're actually seeing living beings from a parallel universe, and they're just because the universes are so close and almost coincident with each other, maybe there's certain conditions that make it possible that you can see the other one. And if we're seeing them, are they seeing us? I think the answer is yes, because when I stepped on the dog, it yanked my leg out from under me. It felt me. It knew I was there, and it reacted like, hey, and ran away. Now, that constitutes, if I'm correct, that constitutes rudimentary communication between universes, if I'm correct. If I'm not correct, then it represents some other kind of hitherto unknown medical event. But I don't know. So the bottom line is I really don't know quite what this was. But that's an event that occurred that I can't explain. It happened right here in my shop. I told Doug about it. I've told a lot of people about it. And I have been met with everything from funny looks to people that want to, dissect my head and my skull. I almost said yes to that, but the money wasn't good. I'm just kidding. So the bottom line was that. So I was really quite taken back by this. And that sort of changed everything, because if I hadn't believed in what people call ghosts before, now I did from a point of view of science. Eventually, we're going to be able to explain this with science. It's not going to make it any less amazing. It's not going to make it any less mysterious. But it's going to be an explanation based on science. Because to be able to put a scientific envelope around something like that is absolutely would be an astonishing feat. And so now we have to gather data. Now we have to try and gather information and data that's different about how we gather data now. We're gathering data based on how we see things in our universe. We're using our eyes. The tools we have at our disposal now are probably not the best tools to try and catalog and understand those types of interactions here in our universe. But because there is not enough mass to have formed this universe, it means that the multiverse concept is probably a reality unless we have grossly misunderstood how mass works in this universe. And if our history is any indicator, we probably have. But taking that into account, in addition, even if you add in some thoughts about what we do know and don't know, adding some little fudge factors for what we don't know, there still isn't enough mass to create a Big Bang unless a parallel universe system actually does exist. And that, my friends, is the most exciting news I have ever heard. We have a caller here. I'd like to invite the caller on. So let's just take the caller right now. Hello, caller. You're on the air. This is Mark. Who is this?
Hi, Mark. This is Ronald.
Ronald. What a surprise. How are you?
What a surprise. I'm doing well. Thank you. So the question I have about your drive, could you, in effect, do time travel? Like, for instance, if you go to, say, the center of the center of our galaxy, we'd be going back in time, correct? And then, if you...
Why would you say that?
Well, because...
Tell me your thinking for why you say that.
We're seeing light from... Well, our sun, we see light 8 minutes later?
Yeah. Yeah. I know what you're getting at. Okay.
So now, if you're looking at the one star you're talking about, 4.3 light years away.
Yeah.
Okay. Now, the center of our galaxy is how far?
Well, depending on where we are, say 28,000 light years to the center from here, maybe 30,000.
Okay. So let's say we can do that little...
Alcubierre shift.
Yeah. And we can get there in how many days? You said 50 days or whatever.
Yeah, we'd be talking about a number of years trying to go use the Alcubierre drive. But I get your point. Let's suppose we did that and got to the center of the galaxy. Would we be looking back in time?
Yeah.
And the answer is yes. Because we would intercept the light trains that are coming from these distant stars at further back in time where they actually left, because time is related to distance in this case. Okay, it takes time to travel all that distance at the speed of light.
Wow.
But if feeding light speed, technically, let's use Alpha Centauri. If we got to Alpha Centauri in 5 days and we look at the light coming to us, we're seeing the light from Alpha Centauri hitting our spacecraft that will then take another 4.3 years to go to Earth. So effectively, we're seeing the light before it gets to Earth, which means we're seeing back in time. You see? That's actually a rather cool thought you had. But because that would mean, in fact, that it's not time travel per se, except in a visual way, you know? But...
Okay.
Well, I'll tell you one thing I'd like to do. I'd like to, take an Alcubierre craft and head toward Betelgeuse in Orion.
Yeah, and see what it's doing.
Well,
that would be fun.
We're going to see it closer and closer to now time. And when we get to it, we're going to see it in...
that kind of goes along with what Bill was asking about, if there would be a time differential on planet Earth, like when we come back, for instance.
No,
would there be a time difference?
That's not true, though. See, that what he was suggesting is their time dilation, based on Lorentz transformations. Okay, that's different. That would not occur using this drive. Okay, that only occurs when you're traveling near or nearly at the speed of light. Okay, then time dilation occurs. You wouldn't be doing that ever in your ship. You would be circumventing all of that entirely. You'd never be worried about that.
Well, let's build it. Let's get it built and let's go. I'm ready.
I know. Yeah, that's a great idea. Well, your questions are great. I want to thank you. Thanks, Ronald. That was actually very, very prescient of you to suggest that we could actually see earlier in the light train of objects. So if we were to go to Betelgeuse, which is roughly 700 light years away, if we could get ourselves Alcubierre'd over to Betelgeuse right now and get there in, say, a week, in 1 week, we'd know whether it was still there or not.
Right.
And then we'd know that Earth, if it wasn't there, then we could go back along the light train with the Alcubierre drive and keep going back until we saw Betelgeuse go off. And from that point, our distance from the Earth would tell us how long it'll be before the Earth sees it.
That would be cool to see that.
Yeah, well, in fact,
all right.
It's a great way to study astronomical phenomena, too. If you had an Alcubierre spacecraft with very advanced telescope systems, you could go and watch the explosion from all sides of the star, right? Because you could defeat the light train, race away from the light train. Okay, we're 2 days from Betelgeuse supernova here. Okay, let's stop, set up the telescopes. All right, in 1 day and in 9 hours, Betelgeuse goes off. All the systems are ready. Boom, it goes off. They capture the data. Okay, let's go. Now you race toward the Earth in Alcubierre jumps, and now you get farther along, and now you're going to be, say, another 1 day away, and now you do that over and over from all different sides if you want, and that'll only work. That'll work forever as long as you want to keep going back. But by the time it gets to the Earth, you'll actually see it. But if you want to observe a phenomena and analyze it, you could do these Alcubierre jumps back from it, by a certain amount of time, and watch the event again and again, because the light train will not have reached that point. Okay, so you're looking at an expanding echo or expanding light train that's leaving these events. And if you can go effectively faster than light, then you can wait for the light to catch up to you again and watch it again.
Wow.
I think that's pretty cool.
Thank you very much for your show tonight. And we do miss Amanda and Daryl, of course. But I hope they feel better, and they'll be back next week. And, of course, you've been doing a real good job, and I did enjoy hearing Bill on earlier and giving his thoughts and perspectives, and it's a lot of fun. And thank you
again. I encouraged him to come on before, but he's been a little bit reticent to do that in the past. But,
oh, no, he's
tonight
shy. He's shy. Yeah, he's shy.
Well, thank you, Ronald. Thanks for coming on and talking. So you have a good night, all right?
All right, bye.
All right, see you later. Thank you. And that was Ronald. And so now there's a few things that I wanted to also mention to you guys. There's a few parts of the human experience. I told you about that dog, the thing that happened to me. That I guess it was a dog. I can't really tell if it was a dog, but it looked like it was a dog. It kind of looked like a Pomeranian or a Pekingese, it was sort of like a little yappy dog like that. In our subjective human experience, we hear about all kinds of things that we don't understand. We saw astronomical phenomena, and we do know that some of those we can explain. Some of those we have explained using dark energy, dark matter. But what about things that we don't really explain well, that we can't explain well? Things like UFO sightings and crashes, whether they're land or sea, abductions, missing time, implants, encounters with extraterrestrial beings. I mean, these are all things that are really, on the fringe, so to speak, for a lot of people in science. They don't want to discuss it because they think it's silly. Well, it's not silly if it's being experienced by people. It's something that has to be dealt with, So, for instance, we've had UFO crashes. We have Roswell, we have Aztec, Cape Girardeau, Kecksburg, thousands of encounters and sightings and rumored crashes. We have ATIP, the Advanced Aerospace Threat Identification Program. Hey, they just came out and talked about this. And there's been lots of reports of submariners seeing objects underwater. And there are even more that have gone unreported. There was one in 2014, a Swedish harbor, a Swedish coast. They saw something. They said it was a Russian sub. But was it? I mean, it didn't have to be. It was there, then it wasn't. They just said, well, the only thing on Earth that fits this is a Russian sub. But they never saw it, nor could they catch it. Now, I had an experience with this, and some of you already know this. So I'm going to paraphrase this experience, so we're in the interest of time. But I was on a nuclear sub as a guest of the Navy. I have done a lot of work for the Navy in the past, and I was never a sailor. But I went on a nuclear sub one time, and I was seasick because I am such a huge, big man here, you know, the big man. And I say big man is like Mr. Important, right? Yeah, well, I got seasick, all right? So no importance there. Anyway, and I wasn't important. I was just another guy. But the fact is, when I was there, I was trying to get rid of my seasickness, so I was sitting in the sonar suite, the area where the sonar guy is listening. And I was just listening and just letting time pass. And as I did, I was feeling a little better, and I was starting to drift off to the humming and thrumming of the sub, the vibration in my feet, you know, of the basic feelings of the sub. And I was starting to feel better. And all of a sudden the kid yells, con sonar, fast mover, fast mover. And for those that have heard the story before, basically it was something that moved through the sonar at hundreds of knots. That's very fast. Okay, hundreds of knots. And they wouldn't talk to me about it. I tried to get the executive officer to talk to me about it. He would not. And a few years later, I went to do a job. I had to do a job for the Joint Chiefs. Okay, and those of you who know who the Joint Chiefs are know that that's important. So I did this job for them, and I asked one of the chiefs about this fast mover program. And I could have been told, I don't know anything about it, or what's that? I wasn't. I was told, I can't talk about that program, Mark. I'm sorry. I drove all the way home from Washington, practically hitting other cars and bridge abutments because I was like totally focused on this revelation that this guy told me. You know, so those are USOs, you know, unknown submerged objects. There's a number of them, a lot of them. And the only reason I started talking about it was because the Russians did. They started talking about it. So I figured, hey, it's not just the Russians. And that's how my conversation started. Well, it's not just the Russians that saw them. Well, how do you know? What do you know? And then I would give a little bit of hinting that I felt like I shouldn't. But then over time, I realized this is not going to be classified material. This is just factual data. I was never made to sign anything to say I couldn't talk about it. And so I basically said, yeah, we've seen them too. And I explained it as I told you, and this is a paraphrasing, of course. But then the other submariners I talked to, they came out and they said, one guy told me that they had another name for them. They weren't fast movers. They called them something else. And other submariners said, oh yeah, on our ship, on our boat, they were this, you know, a submarine's a boat, not a ship. And they said, yeah, on our boat, it was this. And it's like, wow, you know. So interestingly, these are objects that we don't understand that go through our water at high speed. Now, that said, I'm going to throw this at you. There's a possibility. You know, I did a search in the patents. Okay. There are some naval patents that have been just recently granted for ships that actually can travel in such a way underwater that they can move at excessive speed underwater. Now, that doesn't mean they exist already, but they could be. So the possibility is maybe what was witnessed was a black project or a prototype of a black project. And neither the submarine or the crew knew what this thing was, or maybe they did and didn't say. I know the kid did not know what it was because he was downright scared. He was downright scared, the kid that was running the sonar. He was absolutely frightened of what was going on. He had no idea what it was. And, of course, that made me feel a little uneasy, you know, when the guy that's the eyes of the boat says, I have no idea what this is. That kind of became a really, I guess, a little hot button for me, so to speak. Well, anyway, this guy, it was pretty cool, you know. And so is it possible then that maybe these unknown submerged objects are ours? Well, maybe so. Maybe so. So that's something that remains for the future to see. But I do know that as we move forward, we're going to learn a lot more. And I do know that, ATIP is the aerial end, and the USOs still need an unknown submerged object program. And I know Doug Trumbull and I are working on one to do that. That's something that we're planning as well. And I have some ideas for that. And we've been talking to some scientists and folks and that want to help us out. So maybe we'll be able to do this. But if you hear someday about a hybrid aerospace undersea craft, look that up. And you will find about the black projects that we're operating or trying to patent and use now. The hybrid aerospace undersea craft. Let that sink in. And while it's sinking in, I'm going to wish you good night because we've used up all our time here on Sky Tour Radio. Don't forget, subscribe to Sky Tour live stream on YouTube. And we have East and West now. The Western Observatory will be open hopefully at the end of April. And we will be able to broadcast live from Arizona and from Connecticut, probably at the same time. And you see the night sky as never before. Until then, remember, folks, when you go outside, keep looking up. And if Amanda was here, she'd say, that's right, except while you're driving. Good night, everybody.